In this video, we'll learn how to practice finding determinants using trigonometric identities. Here's the first problem. Evaluate determinant of this matrix x sine theta cos theta minus sine theta minus x 1 cos theta 1 and x. Pause the video, try this on your own. Okay, let's do this together. Let's expand this using the first row. We'll have the first element x times the determinant of this 2 by 2 matrix, that's minus x times x, that's minus x square, minus 1 times 1, that's 1. So this is x times minus x square minus 1. This next term will have a negative sign. We flip the signs, plus, minus and plus. So this is minus sine of theta times the determinant of whatever's left if you exclude all the elements that's there in this row and this column. These rows and columns have sine theta. So let's exclude them. We're left with these 4 elements, minus sine theta, 1, cos theta and x. So let's take the determinant of this 2 by 2. We have minus x sine theta, or x times minus sine theta, minus 1 times cos theta. So that's the determinant of this 2 by 2, plus cos theta times, if you exclude these elements, you'll have this 2 by 2, plus cos theta times minus sine theta times 1, minus x times cos theta. Let's be careful about the negative signs. Okay, let's expand this. We have x times minus x square minus 1 minus sine theta times minus x sine theta minus cos theta, plus cos theta times minus sine theta minus plus. So that's plus x cos theta. All right, let's expand this. We have minus x cube minus x minus sine theta times minus and minus. So we have a lot of minus signs. We can take the negative sign common and we can cancel this. Minus is plus. So this will be sine theta times x sine theta plus cos theta. So that's going to be x sine square theta. We have 2 sine thetas here, plus sine theta times cos theta. And then for this one, we have cos theta times minus sine theta. That's minus sine theta cos theta, plus x times cos theta, so that's x times cos square theta. Let's see if we can cancel something. Yes, sine theta cos theta minus sine theta cos theta, this gets cancelled. Here we have x sine square theta and x cos square theta. These two terms have thetas, these two terms don't. So let's separate them. Here we have minus x cube minus x plus x times sine square theta plus x times cos square theta. In fact, we can club x. This becomes sine square plus cos square. That's going to be 1. So this will be minus x cube minus x plus x times sine square theta plus cos square theta. Because this is 1, we have minus x cube minus x plus x times 1. That's just going to be equal to x. So this is x minus x. This gets cancelled. And finally, we're left with minus x cube. So all of this is equal to just minus x cube. In fact, we can say that this expression or this determinant is independent of this variable theta. No matter what theta you put in, no matter what the value of this angle is, this expression is going to be equal to minus x cube. So it only depends on x. It does not depend on theta. Let's take one more. Evaluate this determinant cos alpha cos beta cos alpha sine beta minus sine alpha minus sine beta cos beta 0 sine alpha cos beta sine alpha sine beta and cos alpha. Find the determinant of this 3 by 3. Pause the video, try this on your own. Okay, let's do this together. We'll expand using the first row. This is the element cos alpha cos beta that we pick first times the determinant of this 2 by 2. That's cos beta cos alpha minus 0 times sine alpha sine beta. So 0 times anything is 0. So this is just cos alpha cos beta minus 0. And then we flip the sign. This was positive. This becomes negative. Minus cos alpha sine beta times, let's see what we have. We have minus sine beta times cos alpha. That's minus cos alpha sine beta. Minus 0 times this. That just becomes 0. So this is minus cos alpha sine beta minus 0. Plus minus sine alpha times the determinant of this 2 by 2. That's minus sine beta times sine alpha sine beta. So here we have a sine beta. Here we have another sine beta. So this becomes minus sine alpha sine square beta minus sine alpha sine square beta minus product of these two. This is sine alpha cos beta, that's sine alpha cos square beta. So this becomes minus sine alpha sine square beta minus sine alpha cos square beta. We can take sine alpha common from here. Okay, let's expand. Cos alpha cos beta times cos alpha cos beta minus 0. So that's just cos square alpha cos square beta minus minus plus. This is cos square alpha sine square beta, 2 cos alphas and 2 sine betas. That's cos square alpha sine square beta. What do we have here? We have sine alpha with a negative sign, and these two also have negative signs. So let's cancel them. Take negative common and multiply it with this. So this is sine alpha times sine alpha sine square beta plus sine alpha cos square beta. What do we have? We have cos square alpha. We can take cos square alpha common from the first two. We have cos square beta plus sine square beta. And here we can take sine alpha common. This becomes sine square alpha times sine square beta plus cos square beta. We can see identities applying here. Cos square beta plus sine square beta, that's 1. Sine square beta plus cos square beta, that's also 1. So in fact, we got rid of beta. This just becomes cos square alpha times 1, that's cos square alpha, plus sine square alpha times 1, that's sine square alpha. So this expression, this determinant is not dependent on beta. We eliminated beta here. But if you look at it, we also eliminated alpha. Cos square alpha plus sine square alpha, that's just equal to 1 for all values of alpha. So this means this determinant is equal to 1 for all values of alpha and beta. This does not depend on alpha, nor does it depend on beta. This is just equal to 1.